There are 20 Mesonet systems across the United States in some form or fashion. Some of them are very good. Some of them are just floundering, barely hanging on. One thing or two things that sets Oklahoma's Mesonet program apart from all of the others. Everywhere I've been in this past year, especially in other states, they refer to Oklahoma's Mesonet as the Cadillac system for two reasons. One is because of this, we made fun of it, but this cooperation between OU and OSU. No other Mesonet program in the country have that cooperation between a land-grant university and a school of meteorology that OU has. So everybody's envious of us for that standpoint. The other reason that they're envious of us is our tenure. We've been in existence for 25 years. Started in 1994. January 1 is when the power was turned on to all of the towers in the state, and this is our official 25-year celebration year. So we have that long-term history that no other state can say that they have. If you need data for some reason, back for 25 years, we have it. We probably have it in 5-minute packets. So if you want to see what the temperature was for 24, 25 years, every 5 minutes, we can get that data to you if you happen to have an interest in it. Well, my predecessor, Al Sutherland, has visited with your group several times. I know, I look back at his past calendars. I know he visited with you once or twice a year for the past 2 or 3 years. And I know he has covered our irrigation scheduling tool several times. So I'm not even going to talk about our scheduling tool for two reasons. And I'm going to mention it towards the end, so saying I'm not going to talk about it's not right. But it's an old tool that's fixing to be completely revised, and nobody's using it. I'll be honest with you. It's our least popular tool that we have on the Mesonet system. So that's why we're going to revise it. So I thought, well, what else could I talk about with Mesonet? So I thought I would just kind of give you some other things that I think Mesonet might be useful for you in your operations out there. So here's some things that I thought we would talk about, some of them, not all of them. But it's a great place to get current weather conditions. Just like I mentioned, we can see what the temperature is doing throughout the state at any given time. Soil moisture, soil temperature, that's something you don't typically see, you know, at your on any other weather station out there. Evapotranspiration rates, again, goes into our irrigation scheduling tool. We have, I believe, 16 ag decision support tools. We call them value-added tools, to where we take raw weather data, put them together, and make decision tools that can help you out on various different topics. And then we have forecast, storm advisories that you can get, radar. Those are not ours. You know, we're in the process, or we're in the business of measuring the weather as it happens. We're not in the business of forecasting. But because of that unique location that we have with the National Weather Service, which where we're housed out of, we give them data, raw data of what's really happening today. They give us the forecast data and stuff. So anytime you want to take a look at forecast data that is data before your local weatherman has had a chance to put his propaganda spin on it, you can take a look at our site and you can get what true meteorologists are saying is probably going to happen at the forecast. Now, they're not 100% accurate, and they were definitely off this week with this cold front. They were off 5 or 10 degrees on temperature, and they were off 10 miles an hour on wind speed. So some storms are just hard to predict. And I've already mentioned we've got that historical climate data going back that 25 years since Mesonet came into existence. So here's a map of our current tower locations across the state. There's 120 public towers out there. You can access any or all of them at any time from wherever you're at. There are 7 towers out here in the Panhandle. So I don't think you'll find another weather system that covers the Panhandle any better than the Oklahoma Mesonet does. Each one of those towers, there is a page on the website that you can pull up and look at that tower that's closest to you, or the one you want to look at. This happens to be McAllister. It'll tell you the location, the long and the lat, and it'll tell you what variables are measured at that tower. The biggest block here are the traditional weather-related things that are reported every 5 minutes. So if you want real-time data of what's going on from everything from wind speeds to air temperatures, It's 5 minutes old. By the time we get it to your phone or your computer, it's probably 6 or 7 minutes, but that's as close to real-time data as we can get. In this little block, that's our soil temperatures. Soil temperatures are reported every 15 minutes. Takes a little bit longer to gather those, and then up here at the top, that's our soil moisture. You know, soil moisture doesn't tend to change that frequently or that fast. And the way our sensors work, it takes about 30 minutes for, it uses heat to measure the sensor there. So it takes about 30 minutes for those to happen. But you can look at your local tower or the one you want to look at and see what variables are measured at your tower. This is our web page. It's mesonet.org. There are 4 things that I want to point out on our web page. We'll start off with the weather tab, and we'll spend a little bit of time with that. The forecast tab, again, I'm not going to go into it, but that's a great place to get forecast information if you're interested there. And then the agriculture tab, that's where I work and spend most of my time, and all of my value-added tools are going to be located underneath that agriculture tab. And then lastly, that past data. You can access a lot of that 25-year history without ever having to give me a call. It's available at your fingertips. Just you can click on that tab, plug in what you're looking for, and probably find it right there. If you can't, give us a call. We have the data, and we can get it to you in one form or fashion there. Let's start with the weather tab. This is using the Goodwell station. Once you decide to use the web page, you can select the closest weather tower to you, or the one that most represents your farm or ranch, and it'll automatically stay on that page until you change it. So this is the Goodwell situation, or Goodwell tower. It'll give you a kind of a summary of the forecast coming up in the next 5 days. We use a 5-day forecast, or they do, that we grab. If you want to see hourly forecast, you can click down here, take a look at it in a graph or a table form. You can even export it if you needed to your to an Excel spreadsheet. Over here on the left-hand side for you, I've got an arrow pointing to soil moisture and soil temperature. I think that's something that even if you're not using our irrigation tool, you might find some value in. All of our towers have soil sensors in them. A lot of states don't have soil sensors in their Mesonet program. The sensors here give us more trouble than all of the other sensors on the tower put together. Lightning, I mean, it's a natural grounding source, gophers, just all kinds of issues with soil probes. But it's a challenge, but we try our best to keep those soil probes up and going at each one of the site. The traditional layout is a 2, 4, 10-inch, 24-inch, 4 different sensors in the soil. We use a combination temperature and moisture probe at each one of those locations. Notice that these are under sod, so our sites are located in a natural sod situation, hopefully native range or something that represents a native range situation there in your location. We also keep a bare plot, a chemically treated bare soil plot with a soil probe in it there. It's only the 4-inch probe currently there, but we can simulate a clean till situation versus a no-till under the sod situation. Once you decide what you want to look at, what depth you're interested in, we present that moisture situation 3 basic ways there. The first one is called plant available water. I'm going to show you the 3 maps here, the 3 different ways, all at the 4-inch measurement. This is plant available water across the state November 7th of last year. Second way is plant available water in a fraction or a percentage. So the first one is inches of water. The second one is a percentage. And then the third way is what we call a fractional water index. Now we present that at each sensor at each tower 3 different ways to look at. There's a lot of confusion, and it took me a long time to try to figure out what's the difference between those different ways of looking at soil moisture. I'm going to try to explain it, but if you have any questions, I'll be over here at the side at my booth. Be sure and come and ask me if I don't make this clear enough to understand. On plant available water, even though we have 4 sensors in the soil, it only utilizes 3 of them, the 2, 10, and 24-inch sensors. It doesn't use the 4-inch sensor. So this little red dot would represent the 2-inch sensor, and for a 4-inch plant available water, it only uses that 1 sensor. It takes a measurement there and has a complex algorithm to try to estimate the inches of water in that 4 inches. So it estimates water above and below that 2-inch probe right there, 2-inch sensor. For the 16-inch, it utilizes the 2-inch and the 10-inch. So you can see it encompasses both of them there, again, to try to estimate the total inches of water in that 16 inches, and the same thing with the 32 inches that uses all 3. Now that brings into to mind 2 problems that we have, or I have, with plant available water. The first one is, if this sensor, if we're trying to look at plant available water at 16 inches, if this sensor is not working, this one doesn't work. It's dependent upon the sensor above it to give you plant available water. And especially here in the Panhandle, what happens to shallow soil? It freezes, and when it freezes, we lose this tool. So a lot of times you'll see this time of year that this tool is turned off there. The second thing that I have an issue with this kind of water format is that it is very soil dependent. When we're talking inches of water, you know, individual soils vary so much that we have to know what soil it is to know that whether it makes any sense. And your farm may or may not have the same type of soil as this here. But back on one of the first pages I showed you where you can pick any particular tower, it has a soil breakdown of each one of the towers, so you can kind of see how does that match up with the soil on my farm or ranch to see if this works for me. The other way is fractional water index. I kind of think a fractional water index is just a point in time in the soil. It doesn't try to estimate above or below the sensor. It's just measuring the water as it moves down through the soil. I kind of like to think of it as a gauge. It's measuring how full is that gauge as that water moves down through here. Pros and cons of this: it doesn't tell us inches of water. But one thing I do like about this, it kind of tells me a percolation rate. So I can tell as we get a rain, I can tell how far it reached into the soil, whether it reached that gauge that's further down into the soil profile. So that's kind of an overview of the different ways we look at soil moisture. This is our agriculture tab. Here is a link that'll take you to our Evapotranspiration tool and our Irrigation Planner if we chose to go with that. We call this our the farm monitor, and a lot of producers leave this up on their computer all the time because it has a lot of ag weather information that you might be interested in one page. Now, we all know what evapotranspiration is. These are some of the things that impact evapotranspiration, and of course we record these at each one of the towers. One thing that's missing off of this model or this chart that is necessary for us to be able to figure what actually happens on evapotranspiration is soil moisture. We have soil moisture, but we don't use it in our evapotranspiration model. What we use is something called potential, or I refer to it as the maximum evapotranspiration. So we're telling you kind of like worst case scenario what evapotranspiration might be. We have 2 different ET models, one for a short crop, one for a tall crop, and you can kind of see there what they're referenced to. And it depending on what crop we're trying to match up, you know, we can choose which one of those ET models that best matches what we're trying to grow. You can look at ET, again, on the tall crop or the short crop at a single point in time to see what the entire state looks like at any particular time. Or you can pick one location and look at an entire growing season or a number of years in one location and see what all of the ET is for one particular location. Now here's a list of some of our ag advisory tools, the things that I said we put what I call extra value into, and irrigation is definitely one of those, but these are some of the other ones out there that we have. I think there's 16 when you add them all up in total. We're in the process of redoing all of them, okay? And that's why I don't want to spend too much time talking about the irrigation tool right now. Currently, all of our weather data is available on any phone. You know, I'm talking about wind speed, soil temperature, soil moisture, anything like that's available on a mobile platform. But these value-added tools, for the most part, are not. They're only available on the computer today. But that's what we're revising and redoing. We're trying to make everything we have available to whatever tool you're using, whether a PC, a tablet, or a cell phone out there. Here's an example of our probably most popular ag tool, and this is our spray advisory, and you can see it's just a mock-up, but this is kind of what it would look like on the phone, and you can get a printout of telling you whether or not the forecast is good to spray or not spray. We have about half of those tools already rewritten for a mobile format. The Irrigation Planner we haven't got to yet, so we're fixing to. In fact, we're, with a couple of the researchers that are in here, we're going to meet later this month and start the process of trying to develop it in a format that'll be better use to you, we hope. Now, here is the Irrigation Planner tool. It was developed from Dr. Salih's predecessor years and years ago that we're using. It's never been revised. And one good thing about computer programs or web-based computer programs, I can see exactly whether people are using it or not. Like the spray advisory tool, that's our most popular. We get about 15,000 people a year printing off spray advisory forms. Nobody's using this, okay? Very few on there. We've got people looking at ETs on there, but they don't have to go to this tool to do that. But very few people understand, including me. It's difficult to understand this concept of a water balance in there. So we're in the process of redoing it. I've got a booth over here. I would appreciate any comments that you might have as you're the specialists that are out here using the tool or would like to have a tool maybe. Tell me what you would like to see in that tool. I've already been told we need to maybe consider doing forecast. I would like to see a more interactive tool to maybe plug in when was your last irrigation schedule date so that it simplifies things. But please stop by and see me over here when you get a chance if you've got some suggestions to make this tool better for you out here. We want to develop a tool that is useful out there in the state that is free for you to use for whatever purpose you need to use it for. So.